Hey everybody, we're back. So before we start actually verifying some trig identities, I want to talk about the strategies that we're going to use. The first two being ones that we are always going to use. We are absolutely every single time going to use these two strategies. Okay? We're going to always start with the more complicated side, and we're always going to stay focused on what our final expression should be. Okay? Now, if while I'm trying to manipulate the more complicated side, I am struggling, then I can try to convert to sines and cosines like we did in the previous example. I could work on both sides. So let's say I get the more complicated side to pretty much as far as I can get it, and I still don't have what's on the other side. Maybe I can make the other side look like the same expression that I left off with, and we'll talk about that. And then the last option is if I'm stuck, I can use conjugates, and I'll tell you when the appropriate time to use conjugates is, and when that it's a specific case that you have to recognize, and then if you recognize it, using conjugates is actually the first line of defense, and that those problems go pretty quick. Okay, so let's start with our first example. Okay, we're going to start verifying an identity. So here's our identity. We are going to start with the more complicated side. I think we can all agree that this side here is the more complicated side. Hopefully we can agree on that. Okay? So what we're going to do is I'm actually going to write down so that the reader, grader / me, person looking at your paper, knows which side you started on. So I'm actually going to write left side so that we know we're starting on the left side. So on the left side we have cosecant squared x minus 1 over cotan x. Okay? I'm just rewriting it. Now if I look at the numerator here, this numerator looks like one of my Pythagorean identities. So this looks like the Pythagorean identity that I have. That was, so again, if you don't have them memorized, you can just look at the sheet and that's fine. You could also just start with sine squared x plus cosine squared x equals 1. And then think about if I want cosecant, that's going to be divided by sine squared. So this is divided by sine squared. So this is divided by sine squared. So this is 1 plus cotangent squared equals cosecant squared. So this is just for future reference in case you forget a Pythagorean identity. You can always derive it. And then if I rearrange this, if I just subtract 1 from both sides here, I get cotan squared equals cosecant squared minus 1. So this cosecant squared minus 1, that's what I have highlighted here. That's this part right here. And this identity is telling me that that's not even anything different from cotan squared. So I can replace the highlighted part with cotan squared, and that's still divided by cotan of x. And cotan squared divided by cotan is just cotan. And look, that's the same thing that I have on the other side. Again, I don't want to move things from one side of the equation to the other. I want you to think of the equal sign as like a barrier, and you cannot cross this barrier. So some of you might be tempted to take this cotan and multiply both sides by cotan, and that would give us cotan squared over here, and then you're like, cosecant x minus 1 is cotan squared, done. We don't want to do that. We don't want to move things from one side of the equation to the other. We want to stay on one side of the equation and simplify it until it looks like the other thing. Okay? So make sure that this barrier is in place. Look, I only dealt with the left side of the equation. I got it to look like the right side of the equation, and now I've verified the identity. Okay, let's do another one. Okay, we want to verify this identity. So we're always staying focused on the final expression. That's something we're always doing, and we're always starting with the more complicated side. Now let's talk about what it means to be more complicated. Terms are more difficult to work with than factors. Terms are things that are added and subtracted. Factors are things that are multiplied and divided. I guess technically when it's divided it's called something different, but we have the divisor and the dividend, but it doesn't matter. Let's just go with factors in this case. So it's actually the left side of the equation that's more complicated. So this is the more complicated side. So I'm going to start with the left side again. It's not always going to be the left side, but I think in a lot of these examples, we're going to be dealing with the left side. So we're dealing with the left side. That's the more complicated side because it has these terms. And terms are less simplified than factors. So we have, I'm just going to rewrite. We have secant theta minus cosine theta over sine theta. Now I'm staying focused on the final expression here. So eventually this sine theta that's in the denominator right now is going to turn into a cosine theta. And the only way that's really going to happen is if the sine theta cancels in the denominator and maybe there's some common denominator in this numerator that we can turn into a cosine. And so I'm going to focus on that first. I'm going to change the numerator, so the sine of theta is going to stay the same. And actually, I think we're going to keep this cosine the same for right now. And I'm going to change secant into 1 over cosine theta. Okay? So secant is 1 over cosine. That is a true statement. That is one of our identities. And so now I can come up with a common denominator for the numerator. The denominator would be cosine theta, but if I put a cosine in the denominator here, that means I need another cosine in the numerator. And so I have 1 minus cosine squared theta over cosine theta, and then the sine theta that was down there is still down there. So this common denominator up here got moved down to the denominator, okay? So that's how complex fractions work. If we have something of the form a over b over c over d, that's the same thing as a d over bc, okay? So these are both in the denominator, see? And these are both in the numerator. Okay, so in this case, this cosine theta is my b, and the sine theta that's down there is my c. There is no denominator for the denominator, so both of these are, both cosine theta and sine theta are in the denominator. Those are b and c in that expression. Okay, so now looking at the numerator now, let's do a different color here. Looking at the numerator, this numerator right here, that is looking like our first Pythagorean identity. Cosine squared plus sine squared equals 1. So that means that sine squared equals 1 minus cosine squared. And don't forget that this equal sign means that these two things aren't even different. They're the same. They're not even different things, okay? And so that means that what I have highlighted in blue here is actually sine squared theta And then in the denominator, I still have cosine theta, sine theta. And if I cancel one of the sine thetas in the numerator and denominator, then I'm left with sine theta over cosine theta, which is exactly what I was trying to get. So I have proven this identity. Okay, in the next video, we're going to do a few more examples, and we're going to make sure that we use some of the other techniques that we talked about, like converting everything into sines and cosines, working on both sides at the same time, and using conjugates.